Hi, this is Steve with iFLOW. Welcome to our video series. In this segment, I'd like to introduce to you our cold climate heat pumps. So all of our cold climate heat pumps are designed to be centrally ducted. They're not mini split units. Again, centrally ducted systems to work with our iFLOW hydronic furnace. So in terms of components, we have, of course, the outdoor condenser units from 1.5 tons right up to 5 tons, and then we have the matching evaporator coils to go with those, and then again on a centrally ducted system we have the iFLOW hydronic furnace for a complete ducted system. When you upgrade to an iFLOW inverter heat pump system, we can effectively double the efficiency of your present HVAC system, heating system in particular, of course. And how we do that, we've got very good efficiency on our outdoor units. So we have SEER ratings, SEER 2 ratings, up to 17.5. We have EER2 ratings up to 11.7. And then we have the HSPF2 ratings in zone 4 up to 10.5. In terms of heat pumps, we measure those in what we call COPs, or coefficients of performance. That is a relative number that looks at the energy input and compares it to the energy output and gives you a number. So for example, for every kilowatt in, we get a certain kilowatt out of the heat pump. If we have a COP of 3, for example, what that means is for every kilowatt input, we have 3 kilowatts of output. If we have a COP of 2, we have 1 kilowatt input and we have 2 kilowatts output. So they're very efficient, again up to 300% more efficient than a typical system. If we look at a gas-based system, even though it's not measured in COP, if we look at the concept, right, energy in versus energy out, a typical gas furnace, let's say it's a condensing furnace at 95% AFUE, 97, 98% AFUE, it's still under 1. So what it means is for each 100% of energy in, we're getting 90%, 95% or 97% into the heating, but we lose that little bit, that 2, 3, 4, 5% to the exhaust, and that's on the gas system. So comparing metrics, it would be like if we were trying to give an equivalent COP to a gas-based system, it would typically be under 1, but close to 1 for condensing units. So when we look at a COP of 3 or a COP of 2, that's 200% more, 300% more than what we would typically get on the gas-based system. So definitely some energy savings potential there. We have to offset that with the cost of gas versus the cost of electricity, of course, but we'll look at that. But when we incorporate that into the total heating system, you can see that the cost of operation that we have here, we've got fuel oil being quite expensive, propane is quite expensive, electric resistance heating is quite expensive. So really, when we look at the efficiencies of the heat pump in terms of COP and compare that to even with the cost of electricity versus natural gas, they run very close together. So we can create a very economical cost savings option for you that will allow you to choose your fuel. So for example, you see the dual fuel option. So now you can decide if you want to run electricity, you can run your heat pump for heating. If you want to run gas, you can run your gas furnace or your hydronic furnace with your gas boiler or combi-boiler or tankless water heater, for example. You have the choice to run. So if it's peak electricity time, for example, then you can switch over to gas. Or if the gas, or if it's a very low rate period on the electricity side, then you can decide, okay, I'm going to switch from gas to electric for those periods. So you have the options now to switch between the fuels. But overall, if we are able to run the heat pump for certain months of the year, and then run the gas for, let's say, the heavy lifting in December, January, February, so the coldest winter months, the combined system efficiency will likely double that of what you have now on a typical gas-based system if you had your gas furnace with a typical air conditioner system. So what we would do is we would go in and typically change out your old AC unit put in a new heat pump, and then you have the option of doing your heating both or either by gas or by electricity. With that, we will expect to cut your carbon footprint, so your greenhouse gas emissions, by more than half. So let's look at the heat pump lineup itself. So here we have the outdoor units. So our condenser units, again, from 1.5, 2, 2.5, 3, 3.75, 4.5, and right up to 5 tons. And then we have the matching evaporator coils to go with that, again, from 1.5 right up to 5 tons. You will see as you're matching those pairs, so the outdoor unit and the indoor unit are paired together. They need to be installed together if you're looking to claim any rebate. The paired reference number, the AHRI paired reference number, is here. So we have that reference number for each of these sets. And then we have the eligibility for tax credits in the US, and then for the Greener Homes Grant in Canada, and then the cold climate designation, whether it has it or not, which they all do. In terms of the Canada Greener Homes Grant, there are some units that we have on some of our models that are not yet listed on the grant. They're coming, we expect, in the next couple of months. And then there's some that don't qualify for performance reasons, and we identify those there. So make sure if you're looking to claim any grants or incentives, that you are sure of the requirements for them, and make sure you match them up. If you have any questions, definitely please call iFLOW for any assistance in that. But all to say, we have the outdoor condenser units, we have the indoor evaporator units, and the matching sets. You will notice as you look at them that oftentimes the evaporator coil is a little bit larger than the BTU load or the BTU size of the condenser. And that's because the larger the evaporator coil, the better performance we're getting. So it's a little bit bigger heat exchanger, a little bit more transfer area, a little bit better efficiency. And that's why they're a little bit larger than a typical system may be. In terms of the specifications by the numbers, if we look at, so again, we have the outdoor unit, we have the indoor unit, we have the paired reference, again with the HRI reference, and then we have the cooling capacity at maximum. So this is the maximum cooling that we can get. We have the ER2 again at maximum. We have the corresponding C rating. We have the heating capacity at, again, this is maximum heating capacity at different temperatures. So as the heat pump, as it gets colder outside, the heat pump will have a harder time pulling the heat out of the air. So the actual performance drops a little bit, but we'll go through that as well. We'll look at how much we do, but we have the heating capacity at outdoor temperature of 47 Fahrenheit or 8.3 Celsius, and then we have it at 17 Fahrenheit or minus 8.3 Celsius. So you see the BTU capacity. So we have to look at that when we're sizing systems to make sure we are delivering or able to deliver the BTUs you need at the outdoor temperature in your area, right? So we look at the coldest winter design in January and February. If we're expecting the heat pump to be able to deliver full capacity, we have to be able to size it. We have to look at the numbers at that temperature and make sure we're able to meet your heating load. We have the COPs. So again, you see a COP of almost 3.5, right down to 3. And then as it gets colder outside, the COPs drop because the heat pump is having a harder time extracting the heat from the colder outdoor temperatures. Nonetheless, it's still, if you still look at it, it's still close to 2 in most cases, so 200% compared to your gas-based system. And then we have the HSPF2s for Region 4 and Region 5. So those are the specifications that are listed. That's all in our literature and on our website. This is just to show you that it's there and what those numbers mean. So in terms of the iFLOW the heat pumps, they're all designated and designed for cold climates. So we want to be able to deliver heating to your home fully throughout the winter. So we'll be able to heat your entire home, not just part of it, but for the whole winter. So that's the capability of this system. So even down to minus 20 Celsius, which is minus 4 Fahrenheit, we can deliver 100% capacity out of the heat pumps with a COP of up to 2, so up to 200% compared to the gas-based system. Even though we guarantee delivery of 100% capacity at minus 20 Celsius, but that doesn't mean we stop operating there. We will still operate down to minus 30. The capacity will drop off, the delivery capacity will drop off, but nonetheless we'll still be able to deliver heat into your home down to as low as minus 30 Celsius, which is minus 22 Fahrenheit. Regular air source heat pumps are able to deliver down to typically minus 10, minus 15, which is Celsius, which is, let's say 5 Fahrenheit. But even then, the actual B2 delivery has dropped off significantly, and the COPs are usually significantly less, down around 1.4 or 1.5 perhaps. So the cold climate heat pumps do have a significant advantage over their non-cold climate heat pump alternatives. The iFLOW outdoor units, the condenser units, are fully modulating and self-adaptive. So what does that mean? The iFLOW heat pumps have the ability to analyze the internal temperatures and pressures and the changes in temperature and pressure, and then adjust the system accordingly. So it will be able to look, okay, I'm not delivering a lot of heat. I don't need a lot of heat into the home, so I will drop my operational speeds down. There are other cases where you need more heat, and then it will ramp up. So it'll ramp up and ramp down automatically based on the temperature and pressure changes within the system itself. So there's nothing that we have to do. There's no communication required. The outdoor condenser units are able to do that on their own. So again, when a home needs more heating or more cooling, the outdoor condenser unit will just ramp up or down automatically as it needs. And again, this is very different from a single stage or two-stage unit where they run at 1 or 2 speeds respectively. So if I have a single stage unit, it's just running at 1 stage. So if I need 3 tons or 36,000 BTUs, it's just going to try and run at that level. It's not going to be able to adjust to seasonality or different temperatures within the house. I might not need, I might need, if it's a cold day, I might need 36,000 BTUs in the morning, but if I get some solar gain during the day, I might need to back that off a bit because I'm getting the solar gain from the house. If I continue adding the 36,000 BTUs in addition to the solar gain that I'm getting, now I could overheat that space. So I need the ability to ramp up and down, and that's what the modulation effect gives us. And again, very different from single or single stage or two-stage units in that way. That full modulation allows us to deliver super steady and stable temperatures into the room because we are adjusting in real time automatically to the temperature and pressure changes that we are seeing in the home. So that will result in the ultimate comfort. The iFLOW inverter heat pumps can be paired with any iFLOW hydronic furnace or any other manufacturer equipment for that matter, as long as that equipment is able to operate with third-party 24-volt thermostats. And because of the ability of our inverter to modulate on its own, based on its own internal temperature and pressure changes, we don't need to communicate with any particular model. We don't have any requirement that you have to use our thermostat with our unit and our air handler because that's the only way the system will work. No, we have the flexibility to mix and match with any system out there. Again, as long as that condenser unit, as long as the equipment is able to work with third-party 24-volt thermostats. In terms of operation and the noise levels, our outdoor units can be as low as 54 decibels, which compared to the traditional cube type outdoor units, which were running at about or greater than 70 decibels, you got a significantly quieter operation with the side discharge units. And all of our units are side discharge. So in terms of mixing and matching to make kind of hybrid systems, again, I mentioned that the iFLOW can work in many different situations. So we'll look at a few of them. So in this scenario, we're looking at the iFLOW inverter cold climate heat pump on the outside as our condenser unit, and then we have the iFLOW hydronic furnace in the home with the evaporator, and we're using our smart mode to control it. So where the homeowner is using our iFLOW app that comes with the hydronic furnace to run the heating and the cooling on that system. We can also run with a 24-volt third-party thermostat. So if you want to use a Nest thermostat or an Ecobee thermostat, a Honeywell thermostat, you are free to do so. You can use any thermostat you want. If you're using the iFLOW, the iFLOW hydronic furnace, then you have the option of using any thermostat you want. It does not have to be a hybrid, or it does not have to be a heat pump thermostat. It can be the simplest, most economical thermostat out there. It just wires into the iFLOW, and then the iFLOW controller will decide: do we run the heat pump or do we run the hydronically based system? And that the homeowner can program in some parameters to adjust that switchover point. But all to say, we can run with those third-party thermostats without problem, and they do not have to be heat pump thermostats. So next option, now we're running with the outdoor unit, right? The same iFLOW outdoor unit. We're running with a third-party air handler or a furnace, for example. We're running with a third-party 24-volt thermostat. All we're doing though is we're adding the iFLOW hybrid smart controller. So when we make when we add a heat pump to an existing system, let's say you had a furnace and a furnace and an old AC unit, so we switch out the AC unit, we add the heat pump in. Now we're creating for the first time the ability to do heating through your heat pump and or through your gas side. So we have a little switching controller made by iFLOW that can take the signal from the thermostat. So we have the heating call from the thermostat comes into our controller, and then again we decide whether we bring the heat pump on or whether we bring the hydronics-based or the gas-based system on. So that's what we're showing in this option. And then in the last option we've got the, let's say we're running with the iFLOW hydronic furnace with a third-party thermostat, and we're using a third-party heat pump. We can do that too. So if you've already installed a good heat pump and your furnace has failed, then we can swap your furnace out for an iFLOW hydronic system, run with your existing thermostat, not a problem at all, and still have great switching control. So lots of flexibility in terms of the different systems that we can mix and match with. There's no requirement for, oh, we have this proprietary system. You have to have everything by the same manufacturer, and you have to change everything out at one time. We know that budgets are what they are, and sometimes you'll be able to just be able to change one part of it, and that's not a problem at all. The iFLOW system is flexible enough to work with any of those scenarios. In terms of wiring, the wiring to the iFLOW outdoor unit is very, very simple. We only require 3 wires. So we have a Y wire, an O or a B wire, and then a C wire. So 3 wires going out to the condenser unit. They connect simply to these contacts. So let's look at it. So we have our main power. So we'll have L1 and L2, so leg 1 and leg 2, 120 volts each. They would come in, right, L1 and L2. So that's our main power, 120 volts each leg for 240. And then we have our low voltage wire. So only 3 of the low voltage wires we will have in that system. So we'll have our C wire, we'll have our Y wire, and then we'll have our B wire, right? So our common, our cooling, and our heating. So that's it, 3 wires. That's as simple as it needs to be. Nothing complex about it. The only other thing, we have a bank of dip switches. Dip switch number 2 moves to the up position. That is really it in terms of wiring the outdoor unit. You don't need anything more than that. If you're using the smart hybrid controller, which is, as I mentioned, if we're using an existing furnace, we're not using the iFLOW air handler, we're using an existing furnace or whatnot, we can use the existing thermostat. So even if you only have a minimum, let's say, of 3 wires, let's say you have an R, a W, and a Y, not a problem. You don't have to upgrade the thermostat. You don't have to change the wiring in the wall if it's already, you know, if it's a finished house and you've got a finished basement. Running another line of wire to run a communicating thermostat could be very difficult, very expensive. We can run with that 3-wire. We bring the 3-wire into our controller, and again we send the 3-wire out to our condenser unit. So again, the wiring is very simple, very easy with the iFLOW system. So again, we don't require any heat pump thermostat. Again, only 3 wires thermostat will work fine with our system, and then 3 wires out to the outdoor unit. In terms of warranty, and again, this is as of October 2023. All components out of the box. So when your installer installs it in your home, you have 3 years on all parts, and then 5 years on the heat exchangers and the compressor. If you register within 90 days of installation or in new construction, 90 days from the transfer of the home to the new owners, then you get an additional 2 years for a total of 5 years on parts, and then 10 years on the heat exchanger, right? On the outdoor heat exchanger, the evaporator heat exchanger, and the compressor. With a limited lifetime warranty of 20%, a 20% credit towards the replacement value for the life of the, or for the total time that you own the home. At this point, across North America, with the aggressive decarbonization goals that we have set both at federal levels in Canada and the US, and in state and provincial levels, there are a number of incentives out there. Just looking at the opportunity for the heat pumps, for the contractors, for example. So 47% of the homes in the US, so these are US numbers, are heated with natural gas at this point. So they have a natural gas furnace or a boiler, a combi-boiler, but run with natural gas. 40% are using expensive resistance heaters. So those would be if you're using air handlers, or if you're using heat pumps already with resistance heaters as backup, those are quite expensive to run as well. Baseboard heating, as we know, is very expensive to run. So there are some advantages that we can use with the heat pump, where we're getting, again, those COPs of 3, 3.5, 2.5, even 2 would be a significant improvement. So nearly 40% of the residential AC units in the field right now are over 10 years old, which means if you have an existing furnace and an old air conditioner system that's, again, on average more than 10 years old, you could remove the outdoor unit and put in a cold climate, or put in a heat pump, and then now you have the ability to run the dual system, right? That hybrid system. You can run heating now for the first time. Your old air conditioner just gave you cooling in the summer. It didn't do the heating. Now with the heat pump, it can do your cooling in the summer without problem, and it does your heating as well, or can do your heating as well. So now again, you have that option. So that's the opportunity in terms of the equipment, and just in terms of the ducted systems, because most of the homes in North America will be ducted, centrally ducted. We're seeing kind of a rapid growth in the inverter products for ducted systems, and it's growing at about 20% per year. So for the contractors, definitely movement that way. So if you want to introduce the concept to your potential customers, again, it's a great way to offer them greenhouse gas reduction, so emissions reductions, and at the same time savings, potential savings on their energy costs. Again, decarbonization is a national goal both in the US and Canada. So at the federal and the state and provincial levels, there are different incentives. So you'll have to look at where you live in your area. Are there any municipal rebates, federal, provincial or state rebates, or the federal rebates? Again, I'm not going to go through that, but all to say there are a number of programs out there in the US. Right, the target net zero emissions by 2045, including a 50% reduction by 2032. So those are fairly significant objectives. And again, if we can put in a heat pump, double the effective efficiency of your heating system, then we are in effect reducing our consumption by our gas consumption by 50%. And meeting that target. So this is how we can work together with the governments and achieve or help with the achievement of some of those state and federal objectives. In terms of capital cost reduction, of course, if we can claim any of the tax credits or the rebates or the grants, any of those incentives will help lower your installation cost. Right now, for example, in Canada, with the Greener Homes Grant, all of our units qualify for the $5,000 grant. You do need to follow the application requirements as outlined in NRCan's website. So you need an energy audit before you start the renovation. The energy advisor will come in, they will do an evaluation of your home. You then perform the upgrades. So in this case, you're replacing your existing AC with a heat pump. You're now having a hybrid system. You would qualify for that $5,000 grant. On the US side, again, our system meets the highest tier for the CE's rebates. So again, qualifies for some tax credits on the US side. So looking at the iFLOW complete hybrid system. So again, we have the outdoor units, we have the outdoor condenser units, again cold climate, we have the evaporator, we have the iFLOW hydronic furnace for your complete centrally ducted system. So now we have the entire package. And if you're running with the iFLOW hydronic furnace, then you have the option perhaps of upgrading to a tankless water heater or a combi-boiler. And then we have the plumbing kit to connect the iFLOW hydronic furnace with that. So we have the option of doing our heating electrically through the heat pump, or we have the option of doing it hydronically through the gas side. So again, you have that dual fuel option and capability, both running at the maximum efficiencies of either system. If we're running with an existing system, so let's say you already have your furnace, you installed your furnace 3 years ago, but you still have your AC outside, so we're going to switch your AC to a heat pump. In that case, we're going to use our hybrid controller, and we're going to bring the thermostat into the controller. We're going to set parameters on the controller in terms of the switchover between heating and hydronics. And then we're going to run the heat pump certain parts of the year, and then we're going to run the furnace for the other parts of the year. So typically, if we run the heat pump in September, October, November, when the gas appliances, because the loads will be low, will be typically cycling a little bit. And then we run, or we're going to get the advantage of the higher COPs during those shoulder seasons. And then once we get into December, January, February, where the ability of the heat pump to extract the heat from the colder outside air is a little bit more difficult. COPs will drop a little bit. Then we could switch over to the gas side. So you can run your gas furnace, or you can run the iFLOW hydronic system with using the tankless or the boiler as your backup. We can run that for December, January, and February. And then we can switch back over in March and April to the heat pump. So we're going to run the heat pump for half the season. We're going to run the gas side for half the season, or something like that, to get a combination or that hybrid heating system. And that's what we're looking at. And with the iFLOW, you have the option of the whole lineup coming from iFLOW directly, or as as we said, working with what you have now and replacing perhaps one component this year, and then when the budget allows, then we'll do some of the other change outs at a later date, for example. So that's thank you for your time. At iFLOW, we're looking at an HVAC evolution of product out there. We don't think it's a revolution, but some of the results we're getting are quite revolutionary in terms of performance, outperforming most of the furnaces in the market at the present time. So either way, just better HVAC solutions for the homeowners. So we're looking at energy reduction, cost savings for you, and better comfort delivery with the fully modulating systems. So thank you again for your time. If you have any questions, feel free to reach out by email or call us at iFLOW. We'll be happy to answer your questions. So again, thank you for your time.